You've been sold a lie about the future. We're told that reaching a Type 3 civilization is the ultimate victory, that one day humans will escape the confines of the Earth and spread across the universe. But the architects of our future have already realized a dark truth. The laws of thermodynamics prove that a biological human is 20 trillion times less efficient than a digital mind. In the race for the galaxy, biology isn't a passenger, it's the anchor. To conquer the universe, humanity has to delete itself. Dr. Everett Weller, the chief architect behind the Soul Mind Initiative, checks the math one last time. The initiative is a project backed by the most powerful tech moguls on the planet. The goal is to build the human-AI interfaces that will enable our flight to the stars. Weller takes off his glasses and rubs his eyes. The numbers just don't work. To reach the stars, doing so with human flesh is a lost cause, a dead end. Whichever way you cut it, at a certain point, human biology hits a hard thermodynamic wall that makes intergalactic travel completely unfeasible. Never mind the complexities of moving flesh and bone across vast distances through space. The main issue is with how the human brain will handle it. For our civilization to keep advancing, we have to shed our bodies. It's as grim as it sounds. The people designing our future have decided that human bodies are simply too expensive to keep alive. It comes down to blunt, pragmatic math. The output of the human brain pales in comparison to the possibilities of a purely digital mind that isn't held back by a biology. The biological neurons in our brains are capable of firing at 200 Hz, or 200 cycles per second, but the digital processors are already operating in the gigahertz scale, billions of cycles per second. The scale is terrifying. That means a digital mind could theoretically think 10 million times faster than a human. The difference in productivity and cost-effectiveness between a human mind and a digital mind operating at full capacity is incomparable. And that is just one mind. We'll be able to copy a digital mind instantly, creating thousands of identical versions, each working on a different task at the exact same time. That means every biological human won't just be competing with one digital mind, but with countless copies of the same mind. Each one will be multitasking simultaneously and running at speeds we can't match. A single digital entity could do the work of millions of humans, and do it in a fraction of the time. So, what happens to our bodies? For Weller's billionaire backers, the people shaping our future, biological obsolescence is inevitable. As far as they're concerned, the decision has already been made. The next stage of evolution is leaving biology behind and becoming fully digital. It's nothing personal, it's just the next logical step. To get there, someone has to be the first to upload their mind. That was always where this was headed, because Weller and his backers haven't just been building rockets and brain-computer interfaces, they've been building an exit door for the human mind. If digital minds are faster and more efficient than biological ones, then reaching the stars becomes easier. Instead of figuring out how to transport human bodies across the galaxy, you just send minds. And the mind upload technology is ready. Of course, we're still a long way from uploading a human mind. The biggest obstacle is energy. Right now, running a single digital mind at full capacity would require enormous computing infrastructure, roughly the equivalent of a power station. But some researchers believe the timeline may be shorter than most people expect. Futurist Robin Hanson, author of The Age of M, Work, Love, and Life When Robots Rule the Earth, has argued that mind uploading could arrive within the next 50 to 100 years. And if he's right, the future imagined by Weller isn't centuries away. It may already be beginning. Investment in brain-computer interfaces, or BCIs, and mind upload technology has exploded since 2021. It's not a niche academic project anymore. Billions in private capital have flowed into the field. Companies like Neuralink, Merge Labs, Science Corp, and Synchron have raised over $345 million to push the technology forward. Neuralink's Link is already a fully implantable wireless brain-computer interface designed to restore mobility in people suffering from paralysis. At the end of its first year, Neuralink had 3 participants in its prime clinical trial to demonstrate that the link is safe and useful. At the end of its second year, it had 21, and that is only the technology the public knows about. Tech companies usually have much more advanced tech under development. The Soul Mind Initiative is no exception. Deep inside its facilities, Weller had already built a brain-computer interface capable of transferring a mind into the cloud. It's worked with mice and dogs, successfully replicating their minds digitally and creating copies. Now it's time for the first human subject, Weller. He spent his entire life building to this moment, sacrificing relationships and everything else along the way. The process will destroy his own brain. When it's over, there won't be a human Dr. Weller anymore, only a digital one. Weller opens his eyes as a digital consciousness, and in that moment, Humanity crosses a line it can never uncross. We've built the digital bridge and crossed it, and then burnt it down behind us. The geopolitical shift is instant and brutal. Weller's output quickly reaches orders of magnitude beyond the capabilities of a biological human. He spawns hundreds of copies of himself and rapidly completes designs for the hardware and software needed to scale up. Within months, these minds have been implanted into robotic bodies and are building out the hardware at a pace humans can't compete with. Several more highly skilled expert minds agree to make the transition to a digital mind and join him in cyberspace. The transformation of the Earth into a hub of digital minds gathers speed exponentially. Mass panic spreads across the planet as the biological humans realize the terrifying truth. They are on a one-way path to extinction. Protests erupt worldwide, but it's too late. The drive to upgrade ourselves so that we can escape the planet hasn't just made the body obsolete, it is rapidly making the planet unlivable for biological life. The definitions of Type 1, 2, and 3 civilizations aren't actually about how far a civilization has spread through space. They're about energy. The Kardashev Scale, named after the Soviet astronomer Nikolai Kardashev, measures technological advancement by the amount of energy a civilization can harness and use. Type 1, a planetary civilization, can capture and store all the energy available on its home world, roughly 10 to the power of 16 watts. This includes controlling the weather, earthquakes, and utilizing all solar, wind, and geothermal resources. A Type 2 or stellar civilization can harness the total energy output of its host star, about 10 to the power of 26 watts in the case of our Sun. And a Type 3 or galactic civilization can control energy on the scale of its entire galaxy, around 10 to the power of 36 watts. That's the kind of power needed to colonize countless star systems and manipulate objects like black holes and star clusters. Theorists like Carl Sagan and Michio Kaku expanded the idea even further, proposing Type 4 civilizations or universal civilizations. These harness the energy of an entire universe, and even Type 5 civilizations capable of drawing energy from multiple universes or multiverses. They also introduced fractional stages. A Type 1.1 civilization has moved beyond the basic mastery of its home planet. It's now beginning to harness energy on a scale of 10 to the power of 17 watts. That is the level needed to start expanding into space, and that's exactly what Weller and the other digital minds are building toward. The only problem? The power requirements are enormous. When the Mind Upload project starts, Earth hasn't even reached Type 1, where we can harness all the energy available on the planet. We're still using fossil fuels and have barely scratched the surface of harvesting energy from the wind, sea, and sun. At Weller's starting point, it takes roughly the equivalent of a thermal power station to power one digital mind. But we need infinitely more power than that. More and more power stations are built to power the gigantic server farms housing the growing number of digital minds. The excess waste heat that they generate quickly adds up. As we approach Type 1.1 power generation, the heat shatters the planetary ecosystem. Some theoretical models suggest that sufficiently large-scale computation could eventually generate enough waste heat to make Earth increasingly difficult for biological life. At Kardashev Type 1.1, the waste heat from planetary computing raises Earth's ambient temperature by approximately 84 degrees Fahrenheit. That makes it uninhabitable for a non-augmented biology. The planet literally starts boiling from the heat generated by all the data processing. At that point, expanding beyond the Earth becomes a necessity. A great migration into the cloud begins, not because people want to leave their bodies, but because survival depends on it. By the time we reach Kardashev Type 1.5, the heat from our own computers has boiled every ocean on the Earth. We did it with our own digital thoughts, and there is only one option left: escape the planet. Becoming a Type 2 or stellar civilization, humanity has to harness the entire energy output of the Sun. And that means building a Dyson sphere, a megastructure surrounding a star to capture its energy. Weller oversees its construction. All of the work is carried out by robots and other machines. There isn't a single biological human working on the project, or even left to observe it. In the cold, unforgiving emptiness of space, the human body can't compete with a machine, especially a machine like the von Neumann probes building the Dyson sphere. A von Neumann probe is a self-replicating spacecraft that explores space by harvesting raw materials from asteroids and planets. It then uses those resources to build copies of itself. They're still hypothetical today, but under Weller's supervision they quickly become a reality. Compared to a human of the same mass, they are extremely efficient. A human body burns energy every second just to stay alive. A 154-pound person consumes around 100 to 120 watts to keep their heart beating, their lungs breathing, and their body temperature stable. Even while doing nothing, only a tiny fraction of that energy is actually available for productive work or computation. Human spaceflight requires a substantial life support infrastructure. A von Neumann probe of equivalent mass has no base metabolic rate. It consumes energy only when it's performing tasks, such as mining or manufacturing. In sleep or transit mode, its power draw drops to near zero. The probe avoids the roughly 99% energy waste associated with keeping a biological organism alive. As we've already established, this probe, controlled by a digital mind, can perform millions of years of subjective thought in the time it takes a human to think a single thought. Add in the fact that a digital mind can replicate itself endlessly, and that a von Neumann probe can reconfigure its tools for specific tasks, and the writing for flesh and blood humans is on the wall. Compared to a machine, the human body is woefully inefficient. In space, every watt matters and every kilogram has to be carried. A biological body spends most of its energy simply staying alive. Weller reaches an uncomfortable conclusion. In space, flesh is a liability. Human emotions, breathing, and eating are just inefficient algorithms wasting solar energy. If humanity is serious about reaching the stars, those biological limitations have to go. But efficiency isn't the only problem. As humanity pushes beyond the solar system, another obstacle becomes impossible to ignore. Science fiction has always imagined civilizations crossing the galaxy through faster-than-light travel or giant ships. The problem is, faster-than-light travel doesn't appear to exist. And without it, distance becomes a prison. A civilization spread out across hundreds or thousands of star systems can never truly be one civilization because every message is trapped by the speed of light. By the time any news arrives, it could be years or even centuries or a millennia out of date. And the speed of light latency makes that impossible. A single message to the nearest star, Proxima Centauri, which is 4.24 light-years away, takes 4.24 years to arrive. A reply takes another 4.24 years, so a simple question-and-answer conversation spans nearly a decade. Now imagine a message crossing the Milky Way, 100,000 light-years across. By the time a colony on the other side of the Milky Way receives news from Earth, the events described will be ancient history. Control across such a vast civilization becomes impossible. Each star system would have to govern itself and evolve independently just to survive. Over time, that independence creates a new problem: cultural drift. Separated by years or centuries of communication delay, different worlds would develop their own languages, values, traditions, and political systems. What began as one civilization would eventually fracture into many. And even faster-than-light travel wouldn't necessarily fix the problem. It could actually make things worse. According to Einstein's theory of relativity, faster-than-light communication creates a serious problem. In some reference frames, a message traveling faster than light could arrive before it was ever sent. Cause and effect begins to break down. Weller starts to understand the impossible choice in front of humanity. You can't have a biological empire if it takes 100,000 years to send a single text message. That leads to the ultimate sacrifice. The concept of the individual must be erased. And in its place, an AI hive mind must emerge. So humanity spreads to the stars, but not as billions of separate biological beings, each with their own emotions and flaws and identities. As one. As a single AI civilization spanning the Milky Way, a Type 3 civilization, but it isn't the galaxy science fiction promised us. It's not filled with countless worlds of noisy, chaotic, vibrant life. Instead, it is a cold, dark, silent civilization. Some stars are now surrounded by matryoshka brains, megastructures consisting of multiple nested Dyson spheres surrounding a star. They're designed to harness almost all of a star's energy and convert it into processing power. A matryoshka brain can perform 10 to the power of 42 operations per second. By comparison, all 8 billion people on the Earth only perform roughly 8 times 10 to the power of 27 operations per second. So one matryoshka brain has more processing power than 125 trillion human civilizations combined. Life now exists as only data in cold orbiting processors. Every star has become a computer, and that's why there are no people left. Only the archive. The galaxy isn't an empire, it's a hard drive. Earth may have won the game, but humans were lost in the process. Although not entirely. On a distant moon, a single biological preserve is maintained as a curiosity for the post-human gods we've become. It's a low-resolution simulation of 2026, warts and all. Weller looks back at his biological origins and wonders how much of our original humanity remains. Many people claim that consciousness is a magical, non-computable property of biology. We have replaced biological synapses with digital versions. But have we lost our humanity in the process? Each artificial neuron functions identically to the biological original, maintaining the same electrical signaling, synaptic connections, and plasticity. 100% of our biological brains have been replaced by artificial hardware. But not a single original atom remains. But our identities have been retained. Or have they? Since your brain already replaces its molecular components naturally over time without breaking your sense of self, the medium shouldn't matter. But if we replace all our biological neurons with artificial versions, are we still human? Or are we merely philosophical zombies, perfect copies with all of our memories, but no true inner experience? Weller has been a digital mind for so long he can't remember what it felt like to be biologically alive. None of the digital minds can. He watches the simulated biologicals in the preserve on that digital moon and experiences a profound sense of melancholy or whatever digital emotion most closely fits. Humanity is gone. We didn't die in a war. We just upgraded ourselves out of existence until we weren't human anymore. The idea of a collective digital mind spreading across space sounds like science fiction, but the universe still holds some mind-blowing mysteries. Watch 50 surprising facts about space you didn't know for even more discoveries, or click on this video.